Hi, dear friends. This is a memory boost question from CSIR Net 2023, which was held on 8th of June. The question is like that: there is an infinite potential box of width A, and there are two distinguishable particles which are kept inside one-dimensional infinite box. And in the question, it has been asked to calculate the expectation values of x1, comma x2. So now let us proceed for the solution. So we know that the wave function for infinite potential box is given by under root 2 by a sine n pi x by a. This wave function is for asymmetric potential width. And remember one thing, these two particles are distinguishable particles. So now let us proceed for the next step. X1, x2 can be written as integral 0 to a psi 1 star x1 psi 1 dx1 integral 0 to a psi 2 star x2 psi 2 dx2. x1 x2 can be written as x1 dot x2. As we know that if the potential width is asymmetric, then expectation value of x1 in psi 1 is always equal to a by 2. And if the potential width is symmetric, then x1 in psi 1 is equal to 0. Remember, this calculation is only for distinguishable particles. If you want to calculate for indistinguishable particles, then go for Griffith's book and listen. And the calculation for indistinguishable particles is very important for upcoming CSIR net exams. So now let us proceed for the next step. I will calculate only for x1. Similarly, you can calculate for x2. So now for x1, integral 0 to a psi 1 star x1 psi 1 d x1. So x1 is equal to root 2 by a, and root 2 by a will become 2 by a integral 0 to a x1 into sine square pi x by a. So x1 is equal to 2 by a into half into 0 to a x1 1 minus cos 2 pi x upon a and dx1, that's also x1. So x1 equal to 2 by a into half a square by 2 minus 0, because if you will calculate for next order terms, then cos will become sine, and if you will put a in x1, then sine 2 pi will become 0 and sine 0 will become 0, so this term will become 0. So now you are left with a by 2. Similarly, if you will calculate for x2, you will also get a by 2. So x1 comma x2 is equal to a square by 4. This is from my side of solution. And remember one thing, this calculation is only for distinguishable particles. If you want to calculate for indistinguishable particles, then go for Griffith's book. And calculation for indistinguishable particles is very important for exam. I am again saying it's very important for exam, and maybe in next upcoming video I will try to solve the expectation values for indistinguishable particles. That's all. Thank you.